London dispersion forces. In this video, we will define London dispersion forces, which I'll also call LDFs, and identify when a molecule has them. We will identify which molecules have higher LDFs than others, and learn how a gecko can walk up walls. London dispersion forces are essentially an incredibly weak version of dipole-dipole forces, but they occur in all atoms and molecules, even in single atoms. They occur because electron density can be shifted around a bit in a very transient manner. Sometimes the electron density will get shifted to one side or another. This creates a plus and a minus side of the molecule or atom. They then interact in a similar manner to dipole-dipole forces. However, these are not true dipoles. We call them partial plus and partial minus for the sake of the discussion, but in reality they are far weaker than what you would see in a dipole-dipole. This means that the intermolecular forces, London dispersion forces, are also very, very weak. Now let's think about something for a minute. If you have something like beryllium, which is very small, it's an atomic number of 4, and so it has 4 electrons, as compared to something like strontium, which is much larger with 38 electrons. Which electron density can be shifted around most easily? Take a second and think about this before moving on. Think back to when we talked about polarizability. The greater the number of electrons, the more the electron cloud is able to shift around. This was called polarizability. The same concept applies here. The greater the size of the electron cloud, the more that the electrons can shift around, and this means that it has a greater instantaneous dipole-dipole possible. So to rephrase that, it means that in general, the more electrons, the more London dispersion forces. The more electrons, the stronger the London dispersion forces. It's a tiny bit more complicated than this, given that if you're talking about larger molecules, the shape of the molecule will make a difference as well. However, we're not going to go that far into it. For us, the more electrons you have, the greater the instantaneous dipole possible, and the greater the LDFs. So in summary, the more electrons, the more dispersion forces. And all atoms and all molecules have London dispersion forces. So for any molecule that I give you, if I ask you which intermolecular forces are present, you will always say London dispersion forces. London dispersion forces occur in all atoms and molecules, and they occur because of a random instantaneous dipole, which occurs in all atoms and molecules. The larger the electron cloud, the more dispersion forces that are present.